Hello, my name's Bob Willis and welcome to Defect of the Month. This month I wanted to generally talk about low temperature solders. And low temperature solders have become quite popular to decrease energy consumption, to prevent warpage and distortion of boards and components, allow us to possibly reduce the cost in manufacture based on material costs and also obviously energy costs. So there's a number of advantages. Low temperature materials tend to be tin bismuth silver, and materials which have been slightly modified to improve the long-term reliability of the product. We're talking about the main bulk of the materials reflow at around 140 degrees C. There are materials which are slightly higher, which are the more high reliability alloys. There are lower temperature materials than that, but generally it's the tin bismuth silver materials which are popular. Readily available in bulk alloy for selective soldering and wave soldering, available in solder paste for reflow soldering, limited availability in cord wire for hand soldering and rework and repair, but they are available if you search them out. Now, what I wanted to talk about on this particular video is solder balls. And I tend to find that I haven't really had any problems with reflow and reflow of paste. I really haven't had too many problems with selective and wave soldering, but where I've been using cord wire with low temperature materials, particularly on robotic soldering, I've noticed quite a high level of solder balling. Now, this is a process issue, that's something you can look at, modify and overcome. It's not a robotic soldering problem, but it depends on how you implement the technology. With any hand soldering operation, the key thing is making sure operators are trained to use solder wire, and the actual feed rate and the temperature of the soldering iron must be set correctly, so we're not trying to go faster and faster and faster, because with some cord alloy you might find that the solder spits. And you've seen this in the past during the implementation of lead-free technology and other technologies that we've used throughout the industry. But where we're looking at lower temperatures, you may well find more evidence of spitting with certain brands of materials. Try them out, see if you see this. But the tendency with robotic soldering sometimes is to go faster and faster and faster, as fast as you can humanly go. And if you add solder wire or cord wire directly to the tip in a robotic soldering situation, you may get solder spitting, so solder balls on the product, which you don't want to have, because they're random balls. They're not held in place. They are random balls anywhere on the assembly. So there are a couple of things. One, look at the process, look at the preheating that you introduce, which a lot of robotic solderings don't have, and it can be done. You can use preheating from the blanket of nitrogen that you introduce to the tip and the soldering area. That can actually improve the temperature and the degree of spitting you might see, and may make the process slightly more efficient as well. But one of the things that I've found that is the most benefit is scoring the wire. Now, some robotic soldering systems allow you to score or indent the surface of the wire. And what this does is prevent explosions of solder when you're going through the robotic soldering operation. And I've illustrated this on video clips, and you can see this during this presentation. Now, what we're talking about is just indenting into the wire as part of the process, and this is part of the process of feeding the wire in the first place in an automated system. If you indent into the wire and the indent goes into the core of the flux within the wire itself, when it goes from a solid state into a semi-liquidus and into a liquidus state during the soldering operation, as all alloys will do, there's not that explosion of energy. The flux can escape from that surface before it actually becomes a liquid. So consequently, you are less likely to get that explosive action. So speak to your supplier, evaluate the materials to start off with, obviously, but look to that function of indenting the wire. It certainly does improve the performance and the incidence of solder balling quite significantly. My name's Bob Willis and welcome to Defect of the Month, and I'll see you next time.